Good morning, students. स्क्रीन दिसतेय का? एकाने कोणीतरी सांगा मला. अनम्यूट केलं मी. सार्थक. स्क्रीन दिसते का सार्थक? सार्थक जोशी दिसते ना? आवाज येतोय व्यवस्थित? ठीक. So last lecture, I found some printing mistakes are there in the structure. So I made it corrected. And the new notes, PPT, the PDF of the PPT is also sent to you. Once again, I will discuss some important questions regarding this oxyacids. Oxyacids of these sulfurs, remember. Because for the board examination, these structures are asked for 2 marks, 3 marks or 4 marks. Each structure is asked for 1 mark. So many times this Carros acid, remember this name. This name is not given in your textbook. So I will discuss from this sulfurous acid. It is H2SO3. Sulfurous is H2SO3 and sulfuric is H2SO4, remember. So these two acids are many times asked for the board exam. Draw the structure of H2SO3, draw the structure of this H2SO4. See the structure here. Sulfur having the double bond oxygen, and in case of sulfuric acid, there are 2 double bonds. 1 oxygen is extra in case of sulfurous and sulfuric acid. Otherwise, structure is same. So these 2 structures we can draw, and also we can easy to remember because there are only 1 double bond oxygen and there are 2 double bond oxygens. Then I'm coming to this oleum. This oleum is also called as pyrosulfuric acid. It is H2S2O7. Sulfur having 2 double bonded oxygens are there. See here, 1, 2, 3, 4 is 5, 6, and 7. 7 oxygens are there and 2 hydrogens are there. The 2 OH groups are there on the 2 sides. This is a structure of oleum. Remember, oleum. Oleum, this is also called as pyrosulfuric acid. For the preparation of sulfuric acid, we are using this oleum. Then this Carros acid is, remember the name Carros acid. Those students are preparing for NEET exam and JEE exam. This is asked. What is mean by Carros acid, or what is the formula of the Carros acid? Remember, the formula is H2SO5. This Carros acid is also called as peroxysulfuric acid. Peroxysulfuric acid, remember. So the structure is, we can see how many oxygens are there. 5 oxygens are there. 1, 2, 3, 4, 5 oxygens are there, and 2 OH groups are there. Means 2 hydrogens are there. This is Carros acid. Oxidation state of this sulfur is +6. So make a practice of these acids at your home. Use this slide. Delete the previous notes because I made corrected this structure. This is a disulfuric acid. Peroxy group is there. See, this is a O, single bond O. This is peroxy group. This is also called as Marshall's acid. This name is also not given in your textbook. Marshall's acid, remember this name. Peroxy disulfuric acid is also called as Marshall's acid. So for the NEET exam, JEE exam, this name is used, Marshall's acid. For the competitive exams, those students who are preparing for CET, Carros acid, this Marshall's acid, these names are used. They are not using this peroxy disulfuric acid, but you should know the same names of the acids. So that's why I have given this Marshall's acid also. This is a thiosulfuric acid. Thio, you know, thionyl chloride. This SOCl2 like this. This is a sulfur oxygen bond. So thio group, we already know this thionyl chloride and sulfonyl chloride. This is SOCl2. This is a thio group SO, and this is a thiosulfuric acid. We can see the structure of sulfuric acid and thiosulfuric acid. It is same, only one instead of this oxygen sulfur bond is there. Otherwise these structures are same. See, the structure of sulfuric acid is H2SO4. Two double bonded oxygens are there, and here only this S double bond OS bond is there. So we can remember all the acids. Now these structures are also corrected. Structures of oxoacids of chlorine is also corrected, and it is very easy to remember the oxidation state. It is +1 because the chlorine, it is bonded with only one bond here. We can see the oxidation state here, HOClO. +3 oxidation state. To see the bonds formed with chlorine 1, 2, 3. That's why the oxidation state is +3. Here is +5. We can see 1, 2, 3, 4, 5 bonds are there with chlorine, and here HOClO3, 7 bonds are there. 1, 2, 3, 4, 5, 6, 7. So it is very easy to remember the oxidation state, and these are the chlorous acid. First one is HOCl is a chlorous acid. This is a chlorous acid. Then HOClO is a halous, that is a chlorous acid. Then this is a chloric, and this is a perchloric acid. So first one is a weak acid, and this is a strong acid. Acid strength increases from HOCl. It is a weak acid, and this HOClO3, HOClO3, it is also called as HClO4 because the formula is same, only the presentation is different here. So both the acids are same, HOClO3, or it is also called as HClO4. This is a perchloric acid. It is a more acidic, and this is a least acidic. I think this part is completed. Directly I am starting this reactions of this SO2, chemical properties of sulfur dioxide. Before the chemical properties, I think the reaction with chlorine, reaction with oxygen, reaction with NaOH, this is completed. Once again, I am explaining these reactions. These are the chemical properties of sulfur dioxide, how sulfur dioxide reacts with chlorine, how sulfur dioxide reacts with oxygen and NaOH, and this is a reaction with sodium sulfite, Na2SO3. So out of these reactions, one reaction can be asked for the examination. All these reactions are inorganic chemistry reactions. Practice is the easy method to remember the reactions. Otherwise, there is no any method to remember these reactions. We have to make a practice of these reactions. How the sulfur dioxide react with chlorine. So we have to write the reaction with sulfur dioxide gas plus Cl2. In presence of charcoal, it is used as a catalyst. SO2 Cl2, this is the product. This is sulfuryl chloride, remember. SO2 Cl2, the name is sulfuryl chloride. Then I am coming to the reaction with O2. Sulfur dioxide is oxidized by dioxygen in presence of vanadium pentoxide. This is vanadium pentoxide. It is used as a catalyst, and we get the product here, sulfur trioxide. So twice SO2 plus O2 in presence of this catalyst vanadium pentoxide, we get here twice SO3. Then I am coming to the third reaction with NaOH. The sulfur dioxide readily reacts with sodium hydroxide, NaOH, to form Na2SO3. It is sodium sulfite. So it is a very simple reaction, twice NaOH plus SO2. This is balanced reaction. Na2, we can see Na2 because there are twice Na2SO3 plus H2O plus H2O. So the reaction is balanced, and this Na2SO3 is the sodium sulfite. Remember, if here Na2SO4, it will be sodium sulfate, but it is one oxygen less. That's why it is sodium sulfite. Then I'm coming to the reaction of Na2SO3 sodium sulfite with SO2. So this sulfur dioxide SO2 reacts with sodium sulfite solution because water is added. It is sodium sulfite solution. It gives sodium hydrogen sulfite. See, this is a Na2SO3 is a sodium sulfite. It gives sodium hydrogen sulfite. Then reducing property of this SO2 is sulfur dioxide acts as a reducing agent. Remember, reducing agent means it reduces others and itself undergoes oxidation. Remember, so sulfur dioxide acts as a reducing agent in presence of moisture. First one, moist sulfur dioxide reduces ferric salts. Ferric means Fe3 plus. These are converted into ferrous Fe2 plus. So in this reaction, twice Fe3. These are the ferric. When iron is in +3 oxidation state, it is called as ferric salts, and when it is in +2 oxidation state, it is called as ferrous salts. So twice Fe3 plus SO2. This SO2 acts as a reducing agent. It reduces this Fe3 plus into Fe2 plus. So when it is acts as a reducing agent, itself undergoes oxidation. So twice Fe3 it is converted into twice Fe2 plus plus SO4 2 minus plus 4H plus. Then second one, sulfur dioxide decolorizes acidified potassium permanganate. So the potassium permanganate, you know, it is a pink colored solution. When SO2 is added, the color of the potassium permanganate becomes disappear, it becomes decolorized. So the reaction is given here twice KMnO4. This is a potassium permanganate. Oxidation state is +7. In bracket, the oxidation state is written twice KMnO4 plus 5 molecules of SO2 plus twice H2O. It gives K2SO4 plus twice MnSO4 plus twice H2SO4. These reactions we can balance at your home because there is no any method to remember this reaction. Only the method is we have to make a practice. So many reactions from these chapters are already reduced. In the old syllabus, I think 276 reactions are there. Out of these 100 reactions are already reduced in this year. So this is the most, we can say, in case of inorganic chemistry, this chapter is made quite easy because out of 76 pages, one chapter which is having 76 pages chapter in old syllabus. Now it is only 27 pages chapter. So already many reactions are reduced. So I request all the students, please make a practice of only these reactions because only these reactions will be asked for the examination. Then I'm coming to the structure of SO2. This structure is asked for 1 mark. Draw the structure of SO2. So this structure is same as ozone because ozone is deleted this year due to the COVID-19 situation. The structure of ozone and sulfur dioxide, these are the same structures. Central atom is sulfur, and the bond angle between this oxygen and this oxygen is 119 and 5 degrees Celsius. So these are the two resonance structure. This bond, sulfur oxygen bond, is formed by the d pi p pi bonding. The details of this d pi p pi bondings are not given because from the student point of view, it is expected to only draw the structure. This bonding is not expected. That's why the detailed information of this structure is not given. In old syllabus, the detailed structure of SO2 is given, but in this year it is reduced. How this bonding is formed and how the sulfur dioxide molecule is formed, this is deleted this year. Only the structure is important for the 1 mark. So for the examination, this structure can be asked. Remember, SO2, these are the 2 resonance structure. One sulfur double bond oxygen, and one, this is a sigma bond. This is one sigma bond and one is pi bond. And this is formed due to the d pi p pi bonding, remember. Then the uses of sulfur dioxide I will explain very fast, because we have to complete the chapter tomorrow. Sulfur dioxide is used in refining of petroleum and sugar. Then it is also used in bleaching wool and silk. Bleaching, you know, the colored material, it is converted into decolorized. So bleaching of wool and silk. This is anti-chlorinating agent. It is called as anti-chlor, and it is used as a disinfectant. It is used as a preservatives in the manufacturing of H2SO4, in the manufacture of NaHSO3, it is sodium hydrogen sulfite. Then liquid SO2, it is used as a solvent to dissolve the number of organic and inorganic chemicals. It is also used as fumigation. Fumigation, you know, it is one of the method of pest control, in which the poisonous gases, the area is covered with poisonous gases. So for fumigation as a germicide, it is used. So these uses can be asked for the examination for 2 marks. Write the uses of sulfur dioxide. Any 4 uses we have to write down. Then I am coming to the sulfuric acid. This is another compound of sulfur. So its preparation is very important for the 3 marks. This preparation, sulfuric acid, it is prepared by the 2 methods are there. One is contact process and one is a lead chamber process. But lead chamber process is not included in your syllabus this year. It is deleted. But in the old syllabus, this method was given. So the contact process, this question is asked for 3 marks. There are 3 steps. In contact process, there are 3 steps. In the first step is SO2, that is sulfur dioxide is prepared. In the second step, sulfur trioxide is prepared. In the third step, from the sulfur trioxide, oleum is prepared, and after the dilution of oleum with water, H2SO4 is prepared. So one by one we will explain. In the first step, what is the first step? Preparation of SO2. So this sulfur dioxide gas is prepared by using sulfide ore. This solid sulfide, it is a sulfide ore with burning of this sulfide ore in the air, we get here sulfur dioxide. Or another method of preparation of sulfur dioxide is by using this iron pyrites. This is burning of sulfur, and this is burning of iron pyrites plus 11O2. This is important for us only, SO2. How this SO2 is prepared? So in the step 1, SO2 is prepared. In the step 2, this sulfur dioxide, which is prepared in step 1, which is oxidized with this vanadium pentoxide. This is asked for JECET. Which catalyst is used for the conversion of sulfur dioxide to conversion of sulfur trioxide in contact process? Remember, this question is asked for many times for the competitive exams. So remember the catalyst V2O5, this is vanadium pentoxide. What is the role of this catalyst? It converts SO2, that is sulfur dioxide. SO2 is converted into SO3, it is sulfur trioxide. This reaction is exothermic and forward reaction. Therefore, the low temperature and high pressure are favorable conditions for maximum yield of SO2. Why? This reaction is exothermic and reversible. Reversible means again this SO3 can be converted into SO2. We have to use the low temperature, that is 720, and high pressure. These are the favorable conditions for the maximum yield of SO3. So this low temperature and the pressure is maintained, reversible reaction is not possible. We get the maximum yield of twice SO3. Now in the third step, this SO3 sulfur trioxide gas, we have to convert into oleum. So this sulfur trioxide plus H2SO4, here sulfuric acid we have to use, then it is converted into oleum. Oleum is H2S2O7. H2S2O7, and this H2S2O7 after treated with water, we get here H2SO4. 96 to 98 percentage pure H2SO4 it is obtained by using this method. So this is the industrial method. In industry, sulfuric acid is prepared by using this contact process. So big question is asked on it for 3 marks. 3 steps we have to write down in short. So we can write only one reaction for the preparation of SO2. This iron pyrite reaction, if it is not written, it is okay. We can write this first step, formation of SO2. Second step is formation of SO3. Third step is SO3 converted into oleum, and oleum after treated with water, we get here H2SO4. So it is a very simple reactions. Don't draw diagrams. Diagram is deleted, though the diagram is given in your textbook, but it is not expected from the students. For the understanding purpose, the diagram is given, but in these notes, I have not given the diagrams because it is not expected. Then physical properties of H2SO4. H2SO4, all of you know it is a colorless acid. It is having very high density, oily liquid. It freezes as 283, boils at 6. These are not asked for the examination, but you should know the physical properties. It is highly corrosive, produces severe burns when severe burns on the skin when it touch to skin. So the chemical properties, you know, acidic. H2SO4 is acidic in nature according to the Arrhenius theory. The substances which gives H plus ion in aqueous solutions, it is called as acid. So H2SO4 when dissolved in water, the ions are, it ionizes H3O plus and HSO4 minus. These ions are prepared. Again this HSO4 ions plus H2O, H3O plus and SO4 2 minus ions are prepared. As the value of Ka values is very high, see the value of Ka is very high, means it is called as acidic in nature. So this is for understanding purpose why H2SO4 is acidic, because it gives H plus ion in aqueous solution, remember. Then reaction with metals and non-metals. These acts as oxidizing agent here. When it acts as oxidizing agent, itself it undergoes reduced. So metals and non-metals both are oxidized. See the reactions with metals are given. So the metals also and the non-metals are oxidized by this hot concentrated H2SO4. In these reactions, this SO2 itself gets reduced. So we will discuss this examples. Cu plus twice H2SO4, it gives CuSO4 plus SO2 twice H2O. All these reactions are similar reaction. Then sulfur reacts with twice H2SO4, it gives thrice SO2 plus twice H2O. Then this carbon reacts with H2SO4, we get CO2 plus twice SO2 plus twice H2O. Means in this reaction, this sulfuric acid acts as a oxidizing agent. It oxidizes metals, also non-metals, and itself undergoes reduce. It is also used as a dehydrating agent. You know that there are many dehydrating agents like vanadium pentoxide, it is used as a dehydrating agent. Then sulfuric acid, it is also used as a dehydrating agent. Then alumina is also used as a dehydrating agent. Silica is also used as a dehydrating agent. So one reaction is given here. This is a C12H12 H22O11. This is a sugar. Dehydrating agent means water molecule is removed. So sulfuric acid, when the sugar is heated with sulfuric acid, this sulfuric acid absorbs the water molecule, and we get here charcoal. Black colored sugar charcoal is prepared, and these molecules are absorbed. These 11 H2O molecules are absorbed by the H2SO4, and this is a black charcoal is prepared. This method is called as charring, remember. This process is called as charring. Which process? The process of removal of water molecule from the sugar by using H2SO4. This method is called as charring. This is asked for 1 mark. And student neglects this reaction. So don't neglect this reaction. What is meant by this charring? Charring means removal of water molecule from the sugar. So one problem it is given, what is the action of concentrated sulfuric acid on HBr and HI? So when this H2SO4, both are acids. This is hydrobromic acid and this is sulfuric acid. So the concentrated sulfuric acid oxidizes this hydrobromic acid into bromine. We can see here H2SO4, when it is added in twice HBr, we get here Br2 plus SO2 plus twice H2. Same reaction for hydroiodic acid. H2SO4 also oxidizes this hydroiodic acid into iodine. So this is bromine, this is iodine, other products are same. So this reaction, it is not included in the text, but for the examination, it can be asked, what is the action of concentrated H2SO4 on HBr and HI? So each reaction can be asked for 1 mark for the board examination. Then reaction with salts, you know, this is a common salt, NaCl. This is also the one salt, potassium nitrate, and this is a calcium chloride. So all these salts, when H2SO4 reacts with these salts, corresponding acids are prepared. So NaCl plus H2SO4, it gives NaHSO4. Now again, these are the salts plus acid, salt plus acid, salt plus acids are prepared. Then I am coming to the uses of sulfuric acid. You know, this is a very famous laboratory reagent. It is used in laboratory. Also, it is used for the manufacturing of fertilizers. Fertilizers, which fertilizers? The names are given: ammonium sulfate and superphosphate. Fertilizers are prepared by using this sulfuric acid. Then it is also used in the manufacturing of pigments, paints, dyes, industries. As intermediate, it is used in petroleum refining, in detergent industries, in metallurgy for cleaning the metals, electroplating, and for galvanizing. In batteries, storage batteries, whatever the batteries we are using in the automobile batteries, in storage batteries, it is used laboratory reagent, and in the manufacturing of nitrocellulose products. So any 4 uses we have to remember if it is asked for 2 marks for the board examination. Each use having half mark. If it is asked for 1 mark, we have to write 2 uses. If it is asked for 4 marks, we have to write, if it is asked for 2 marks, we have to write 4 uses. Then I am coming to the chlorine. This is chlorine and its compounds. This is another new topic started. So first step is the preparation, how the chlorine is prepared. So chlorine can be prepared by using different methods. First one, you know, this manganese dioxide. Chlorine can be prepared by the oxidation of hydrochloric acid with any of the following oxidizing agent. So this is manganese dioxide, MnO2 plus HCl. MnO2 plus HCl, we get here MnCl2 plus Cl2 and plus twice H2. Here, this chlorine is prepared. Again, it is also prepared by using potassium permanganate, twice KMnO4 plus 16 molecules of HCl. So by making practice, we have to remember these reactions. how the chlorine is prepared by using manganese dioxide, how it is prepared by using potassium permanganate. So the two molecules of KMnO4 plus 16 molecule of HCl, this is balanced reactions. Twice KCl plus twice MnCl2 plus H2O plus 5Cl2. This is a required product. So the chlorine can be prepared by using manganese dioxide and potassium permanganate. It can be also prepared. So the chlorine can be also prepared by the concentrated sulfuric acid on the mixture of NaCl and manganese dioxide. So in the first step, if NaCl reacts with H2SO4, this reaction is already learned. See this reaction, same reaction is repeated here. NaHSO4, NaHSO4 plus 4HCl, and if this HCl, first this sodium chloride reacts with the sulfuric acid and this MnO2. This reaction is again repeated here. See, the reaction of this manganese dioxide with HCl, it gives MnCl2 plus twice H2 plus Cl2. So these two reactions are already completed. So first one, by adding these two reaction we get here 4 NaCl. So see, 4 NaCl is written here. Then MnO2 as it is written here. Then 4 H2SO4 written here. Then it gives the product sodium hydrogen sulfate for NaSO4 plus MnCl2. This MnCl2 twice H2 and Cl2. These 4 HCl and these 4 HCl molecules are removed. So this is a third method of preparation of chlorine by using NaCl and MnO2 by using. If it is asked for the examination, it will be asked for 2 marks, and the question will be like this: write the preparation of chlorine, or how will you prepare chlorine by using NaCl and MnO2. So we have to write these reactions, 2 reactions. Then this is the preparation and this is manufacture. There is a difference of preparation and manufacture. Remember, this is manufacturing means for the industry. For industrial method, this manufacture word is used, and this preparation word is used for the laboratory. Remember. So this is the preparation of chlorine is different and manufacturing of chlorine is different. Manufacture of chlorine, there are 2 methods are given in your textbook. First one is Decon's process. This is very famous process by which chlorine can be prepared for in a large proportion, in bulk proportion. For the industrial method, it is prepared by using oxidation. So what is this Decon's process? This is the name of the scientist Decon who prepared the chlorine by using this method. So this is an oxidation of hydrochloric acid by using atmospheric oxygen by using this catalyst Cl2. It is a catalyst. We get the temperature at 723 Kelvin. We get the chlorine. So this is a industrial method preparation of chlorine. 4HCl plus O2. Oxidation with atmospheric oxygen, twice Cl2 plus twice H2. So this method is very IMP. Remember, for 1 mark it is asked. Write the method of manufacturing of chlorine by Decon's process. Then this method is also we learned in 11th standard, electrolysis process. Electrolytic process. The electrolysis of brine means it is a concentrated NaCl solution, salt solution. So electrolysis, you know, the electrolysis when 2 electrodes are dipped in the solution, and these 2 electrodes are connected to the electric circuit here. Anode, one is anode and one is cathode. So this NaCl ionizes Na plus and Cl minus in water. So see, this is a chlor-alkali process. This is a chlor-alkali process. This is a solution of brine solution is there. So this is not expected, but for your understanding purpose, I have given this diagram how the electrolysis takes place. So on the anode, see this anode, the chlorine gas is liberated from this anode, and to this cathode, hydrogen gas is liberated. See, so we can see here anode, chlorine gas is liberated, and to the cathode, hydrogen gas is liberated. So this diagram is not expected for, but for the understanding, I have given this diagram how the electrolysis takes place. So on the cathode, say twice H2O molecules accepts the 2 electrons, and this hydrogen gas is liberated. And on the anode, this chlorine gas is liberated, remember. So this can be asked for 1 mark for the board examination. Write the manufacturing of chlorine by using electrolytic process. Then physical properties of chlorine. All of you know chlorine is one of the gas. It is a greenish yellow colored gas. It is having pungent and suffocating odor. It is poisonous in nature. This chlorine gas can be liquefied into greenish yellow liquid, which boils at 293 Kelvin. It dissolves in water to form the chlorine water. It is 2 to 5 times heavier than air, remember. This gas is very dense. So these are the physical properties which are not asked for the examination, remember. Then chemical properties of chlorine. Chlorine reacts with metals to form chlorides. And also it reacts with non-metals also to form their chlorides. So these are the very easy reactions. When the chlorine reacts with aluminum, aluminum chloride is formed. It reacts with sodium, sodium chloride is formed. When it reacts with iron, ApCl3, it is formed. Then when react with phosphorus and sulfur, these are non-metals. It forms the phosphorus trichloride and sulfur chlorides. So these are the reaction with metals and non-metals. Then reaction with hydrogen. When this chlorine reacts with hydrogen, Cl is formed. When these reacts with hydrogen or hydrogen containing compounds, remember. This H2S is a hydrogen containing compound. We get here hydrochloric acid, it is formed. Cl2 plus H2, twice HCl is formed. In this also twice HCl is formed. Then reaction of ammonia, this is IMP for the examination, remember. So all the reactions are actually important for the board examination. For 1 mark it can be asked. Then it is the reaction of ammonia with chlorine. So excess of ammonia, chlorine reacts with excess of ammonia. Or excess of ammonia reacts with chlorine to form here ammonium chloride. And chlorine when reacts with excess of ammonia gives ammonium chloride and also nitrogen. In the first reaction we can see clearly 8 NH3 molecules in excess plus thrice Cl2 ammonium